Well, hi there and welcome. We're going to be looking at determinants today, and we're going to use the determinants to find a solution to a system. And using determinants to do that, that's called using Kramer's rule. So a determinant is basically a new operation that we're going to do. We're going to do this on matrices, and how it will be represented is two straight lines down. So when you see two straight lines down over matrix C, what that means is if it's a 2 by 2, you just multiply A times D and subtract B times C. So let's play a couple of those. So as long as it's a 2 by 2, it's pretty straightforward. I would just multiply 2 times 4 because that's in the A and the D position. So that would be 8 minus 3 times 1, that's a 3. The determinant of this matrix C is 5. Let's throw a few negatives in here. Negative 2 times 2 is negative 4, minus negative 1 times 4 is a negative 4. Performing this computation, looks like I have a 0 for this guy. And then I'll do one where we have a 0 in here. So 3 times 4, that's 12, minus 1 times 0, that's 0. The answer to that determinant is 12. So let's do Kramer's rule. Okay, so here's Kramer's rule. Let's see what it says. We've got two equations. Well, I have two equations sitting right here. I see them. And it says that the 2 is in the A1 position. So I'm just going to write this down. The 2 is in the A1 position. There's an X. So that's a 2. In the B1 position, I have looks like a negative 3. In the A2 position, or the A position equation 2, I have a 4. And in the B position next to the Y in equation 2, B2 is a 5. Then C1 and C2, so whatever it equals, or that constant, for the first one it's a 4, and for the second one it's a 3. So make sure you know where I got those numbers. Then it says what you can do is you can find X and Y using these numbers and finding the determinant. So let's find our capital D first. Capital D is going to be A1, B1, so that's 2, negative 3, A2, 4, B2 is a 5. Let's compute this determinant. That would be 10 minus a negative 12. So this answer is 22. Let's do dx. dx is, I take C1 and B1. So C1 is a 4, B1 is a negative 3. C2, that's a 3. B2, that's a 5. Let's compute this. So that would be 20 minus 3 times, that would be a negative 9. So this would actually be 29. Okay, so let's scroll just a little bit. dy is A1, that's a 2. I'm looking right here now. A1 is a 2, C1 is a 4, A2, that's a 4, C2, that's a 3. Let's take this determinant. That would be 6 minus 16. This would be a negative 10. All right, almost home. Now what I need to do is X equals dx over d. X is going to equal dx, 29 over 10. Woo, that's an ugly answer, isn't it? Y equals dy over d. Y is going to equal dy, that's negative 10, over, let's see, capital D is a 22. 22, I guess I could say that you simplify to negative 5 over 11. Ooh, those are not very pretty answers, are they? So let's look at this equation. because we know we could have solved that by elimination or substitution. But notice I wouldn't have wanted to use substitution on this. I wouldn't have, you know, I could have used elimination. I would have multiplied that top one through by a, -2, and that would have gotten rid of the x's. So that would have been an okay thing to do. But this is just another method to solve a system. Okay, we're going to do determinants for 3 by 3 matrices. And yes, you can also extend this to solving equations for 3 by 3s using Kramer's rule, but those get tedious, as you can well imagine. So we'll just stick with, in this class, we're just going to stick with the 2 by 2s on Kramer's rule. But you do need to know how to find the determinant of a 3 by 3. So that's what we're going to do here. So in order to find the determinant, notice we have 2 straight lines down on this matrix, so that means find the determinant. You decide which row or column that you're going to expand on. So here's our how to, and I know this looks very confusing, so I'll just kind of start right here and say how to, and then we'll go through what the definitions are as we go down through here. We can expand on any row or any column. I'm going to expand on row 1 just to make it easy. So what I will need is I will have a, let's see, I will have a 1, and then I'm going to multiply that because I want the product. Take that 1 and multiply it by, I write down the elements that are not in that 1's in this guy's column or row. So that would be, I'm looking at these 4 right here. So I'm going to write those down. So 0, 1, -1, 1. Then I'm going to use the 3. Notice he comes next. So I'm going to use the 3. And I'm going to write down those numbers. Of course, I'm writing this way too big. I'll fix that. I'm going to write down those numbers that are not in his column or row. So the numbers that are not in his column or row would be those guys. So I'm going to write down that 2, 1, 4, and 1. So let's write them down. 2, 1, 4, and 1. Scooted that over for you. Now, I use the sign that is in this little list here. Since I expanded on the first row, the 1 is positive, I minus the 3, and I plus, of course it has to be a -2, the -2 times the determinant of whatever is not in his row or column. And that would be these dudes. So I'll write down 2, 0, 4, -1. Let's get out of there. 2, 0, 4, -1. And at this point, it's just a matter of computation. It's going to be 1 times 0 times 1 is 0 minus a -1, so that's a +1. Minus 3 times his determinant is 2 times 1. 2 minus 4 is, I'll just write 2 minus 4. And then plus -2 times -2, looks like -0, so I'm not writing that down. So this is 1 minus 3 times -2 plus 4. So looks like to me this guy equals 11. And that'd be the determinant of this 3 by 3. And you might be asked to expand off a different row or column. You just circle that row or column and you just proceed. Like if I were to work off of this row, then I would have had, let's see what we got really quickly. If I can get, all right, so remember I'm going to expand off of this bottom row here. Let's play this game again. It's going to be 4 times the determinant of whatever's not in his row or column. So that would be these dudes right here. So I'm going to write down 3, -2, -2, 0, 1. Then, since I'm on the bottom, I have a plus, then I have a minus, so it's minus and a negative 1 times the determinant of whatever is not in his row or column. So that would be this 1, 2, and the negative 2, 1. So I'll write that down. And that would be, what did we say it was? Negative 1. So we were doing 1, 2, negative 2, 1. Then I look here and I have a plus for the next one. So it's plus, and I got a 1. Write that down if you want to. And then I'm looking at these guys here. 1, 3, 2, 0. So I have 4 times 3 minus 0. Okay, I'll just write that down. Plus, because negative times negative is a positive, that's just a 1, so I'm just going to write down 1 minus a minus 4. Okay, so then we've got, that was just a 1 there, so that's 0, oops, not equals plus 0 minus 6, so that's a minus 6. So let's see, we have 12 plus, that would be a 5 plus negative 6. So if I were to add all of these things together, it looks like I would get 11, which would be what I would expect since I got 11 the other way, which means it doesn't matter which row or column that you expand off of, you're going to get the same answer because the determinant of that matrix is 11, no matter which way you slice it. All right, if you need any help, you be sure and email me and let me know what I can do for you. Have a wonderful day.